I'm Jenifer Hepzibah of ME VLSI Design from Veltech. My project supervisor, Mr. B. Vignesh Raja, Assistant Professor of EC Department. Project title, Mixed Signal Approach for a Dual Mode Pulse Amplitude Modulator using CMOS 90 nanometer technology. Mixed signal approach, I have combined both analog and digital modules. Some modules are designed with the analog approach and other modules are designed with the digital. So that I have reduced the area and power in my project. I have used dual mode, common mode and differential mode. Pulse amplitude modulator, transmitter, modulator by which transmitter and receivers are designed using CMOS 90 nanometer technology. The channel length is very much reduced. The transmitter and the receiver is connected by a serial link. And the pulse amplitude modulation is used to transmit the signals from transmitter to receiver. In this project, I have reduced the power dissipation and delay. Existing, they have used 180 nanometer technology. The power dissipation and area are mentioned in the existing design. In the proposed design, I have reduced the area and power. I have used 90 nanometer technology so that the area is very much reduced. These are my literature survey. In my base paper, they have used 180 nanometer. My third literature survey says that low power encoder design for a 5 flash ADC. This is my block diagram. Pseudo random bit generator for a built-in self-test. These are it gives 6-bit parallel pseudo random bits, and these are multiplexed by 4x1 multiplexer and encoded, and this multiplexing is controlled by the select clock dividers of 2 selection bits. The receiver receives and it decodes. The transmitted input is received finally. These are my modules. Some modules I have used digital and others in analog. Digital I have used encounter and analog, which so in CADENCE tool. Pseudo random bit generation of 16-bit parallel output, RTL, and the power and area calculation, GDS2 final output, like that for divider, power and area, worst case slag, power GDS output driver have designed it with analog, output driver output. These are the encounter transmitter output at the out 1 and out 2 of the transmitter. Flash ADC comparator and decoder, or these are the working methodology of the receiver, some in virtuoso and other in encounter. Cadence flow I have used tools. For digital tools I have used these tools. By digital flow is by means of coding. I have used the analog mixed signal approach, AMS, in Cadence to combine these things. Flash ADC I have used 10 comparators in this to design 8-bit flash ADC. And the proposed comparator I have used double tail comparator. Comparator symbol is designed, and then the simulated output of the comparator and the power waveform is generated for power analysis. Decoder simulation results and the RTL diagram, power and worst case slack paths are calculated. And finally the decoded output is the transmitted input is received. This is the transmitter output, GDS2 decoder layout. Conclusion, I have concluded with the area of 0.23 cross 0.67 and the power dissipation of 198 and 177 for transmitter and receiver respectively. These are my references.